Welcome back to the chemistry notes. Again, this is part 5. Again, there may seem like there's a lot of notes, but we actually broke them down into smaller segments. Typically in a class, we take notes over the course of 2 or 3 class periods, but we actually broke it down into much smaller parts. So instead of sitting down and taking notes here for 40 minutes or an hour, we've cut back. We also have more explanation in these notes, so if you were absent from class, hopefully these are going to be a little bit more detailed for you. Now the first thing I want to do today is I just want to take a quick review. Remember, what you see here is a periodic table of elements. We talked about this in an earlier section. And remember, we called these up here. These are called groups. Sorry, just need to get a pen. See if this works. Okay, just got to get a little bit thicker ink here. Okay, so remember, these were called groups, right? You guys remember that? Okay, and this is your first group, this is your second group, this is your third group, and it goes all the way over to 18. Okay. Now, if you remember, on the sides, this right here, these were actually called periods. And one of the ways I always remember that they're called periods and not groups is because they're horizontal. What do you find at the end of a horizontal sentence? You find a period. Now, this period is the first period. This is the second period. This is the third period. And the reason why I'm reminding you of this is everything in this row, so both hydrogen and helium here, both have the same outer shell. For example, hydrogen will have 1 electron in the L shell. Helium has 2 electrons in the L shell. Now, once we get to period number 2, this actually, you start to introduce, not, what's the second shell? The first one's the K. What's the second one? It's the L. So everything in here will have an L shell for the outermost shell. So lithium has 1 electron in the outer shell. So remember, these numbers right here were the number of valence electrons. So beryllium will have 2 electrons in the L shell. And then we go over to here. This boron will have 3 valence electrons, 4, 5, 6, 7, and 8 valence electrons. So knowing this information is really convenient when we start talking about bonding. Now, we talked about ionic bonding in the last segment. Today we're going to talk about covalent bonding. Covalent bonding is the sharing of electrons. Remember, ionic bonding was the giving out. Now, in covalent bonding, both atoms attract the shared electrons at the same time. This often forms between 2 or more nonmetals. So let's back up to here. Remember, we talked about how you can have metals and nonmetals. Typically, in a periodic table, things over here tend to be your nonmetals. Things like oxygen, fluorine, chlorine, argon. Things over on this side tend to be your metals. So it forms between what? So if we go again, we go to the next slide, forms between 2 or more nonmetals. So typically it forms with these over here. So we can kind of break it up. If you remember, there's that stair-step pattern in here that has the metalloids. So these are going to be your nonmetals. You got your metalloids, and then you have your metals over on this side. So when we take a look at covalent bonds, it's 2 or more nonmetals. So it's going to be things over here. And one of the reasons why covalent bond is a sharing of electrons is because they require just a few electrons to be completed. So one common example of that here you see is hydrogen and oxygen. Now if we back up, one thing I do want to point out is hydrogen over here is actually considered to be a nonmetal. So you got hydrogen over here, and we have, let me erase that for you. So you can see hydrogen right there. So hydrogen definitely is a nonmetal, and oxygen is a nonmetal as well. So when it says 2 nonmetals, that's why. So ionic bonding was the giving up, Covalent, remember co meaning two, covalent is, um, remember, it's kind of like, cooperation is where you work together, you share things. So it's two or more nonmetals. So here we have hydrogen and we have helium. Hydrogen, this is the K shell. Here's your K shell. Now oxygen, you'd have a K shell in here, but we don't need to know that. We only need to know the valence electrons. So this is your L. Now, the L needs how many to be considered full or stable? It's going to need 8 electrons. Hydrogen, it needs how many? This is the K shell, it only needs 2. So it's missing one, but the oxygen actually needs 2 more. So what happens is that these will combine, and hydrogen will share an electron. Each hydrogen shares an electron with oxygen, and oxygen will share its electrons with hydrogen, and that's why you get water. And one of the ways of saying water chemically is to say H2O. And what does that mean? That there's 2 hydrogen and 1 oxygen. So when we look at this one, this is actually methane. How many valence electrons does hydrogen have? Well, again, we just talked about in the last slide. It just has the 1. Now here they actually put the K shell in here as well as the L shell. So you can see both. So how many valence electrons does hydrogen have? Well, it has 1. How many does hydrogen need to be full? We just talked about that. The K shell needs 2. So how many valence electrons does carbon have? Well, let's count. We got 1, we got 2, we have 3, and we have 4. So it has 4. Now how many does it need to be full? Well, we just talked about that. That second shell needs 8. So somehow it's got to pick up 4 more. So what did it do? Well, each hydrogen will share an electron with it. So if we take a look at, there's 4 hydrogen. This would be CH4. So there's 4 hydrogen. So those 4 hydrogens, you add those 4 to this 4, you're going to get 8. And look at it here. Carbon is sharing an electron with hydrogen, so now it has 2. So 1 plus 1 equals 2. So here are some different elements that are different compounds that you can see. We already dealt with your methane right here. We just said it was methane. You got ammonia, and you got water. And what are the formulas for these three covalently bonded molecules? Well, we got C, there's 1 carbon, CH4. Here we know this one, you got H2O. And here you have NH3. So what is the formula for this molecule? Well, first of all, let's take a look at it. What is it? Well, down here we can read that it's hydrogen. And I know it's hydrogen because it only has 1 electron in the outer shell. Now, it does say hydrogen. If this was just showing the outer electron, I suppose it could be lithium as well. So it is hydrogen. Now, hydrogen needs 1 more to be full because this is your K shell. K shell. So what hydrogen will do sometimes is it'll actually bond with itself, and it will form H2O. And the reason why it does that is so that it can be stable, because as long as the outer shell is full, it tends to be stable. Now some atoms actually pull more strongly on the shared electrons than other atoms do, and as a result the electrons move closer to one atom, causing the atom to have a slight electrical charge. Now a covalent bond in which these electrons are shared unequally is considered to be polar, and we'll call it a polar molecule. So when you're in class, we do a lab on this where we actually build a polar molecule. So let's take a look at this right here. If we remember, this is what? This is H2O. So it's water. Remember what happened with water? Hydrogen needed 1 more electron to be full in each outer shell. So it shared its electrons with hydrogen. Hydrogen actually needed 2 more to be full, so that's why it's bonding with the 2 hydrogens right here. Now if you look at this, oxygen has a much larger mass. It's a much larger atom. So when those electrons are orbiting around oxygen, it's going to spend more time orbiting oxygen than it will hydrogen, because hydrogen is a lot smaller. And because those electrons spend more time orbiting around the oxygen, it will actually create something, what we call, it will create a negative charge, because remember, electrons are negative. And because the electrons are spending more time with oxygen, these will have a positive charge, because if the electrons are spending more time with the oxygen than with the hydrogen, it'll have a slight electrical charge. And when we have positive and negatives together, this should remind you of something. Does it remind you of a magnet where you have a positive side and a negative side? Hopefully it does. And this is one of the reasons why water tends to stick together. If you've ever taken a coin, try this once. Take a coin, a dime, a nickel, a penny, and put drops of water on it. And what you're going to find is that you can actually get this water to form a little dome. Or take a cup. If you take a cup and you fill it with water, you can actually get a small dome on top of it. You can actually look from the side and you'll see that it bubbles up. Or if you've been in a shower and you see that water tends to come together and go down the shower curtain together. That's because water is a polar molecule. It wants to stick together. Now, if you took something like rubbing alcohol and you tried taking a coin and doing the same thing right here, it would not work. The water would be, well, it's not water, it would be rubbing alcohol, but the reason why it won't work is because it's not a polar molecule. So it doesn't work with rubbing alcohol. But this right here does work because water is a polar molecule. So what is a molecule? I've mentioned molecules several times. Molecules are combined atoms. And they may be either covalent or ionic bonds. So as long as you have two bonds put together, it really does not matter whether it's ionic or it's covalent. It doesn't matter. It's just that there's two atoms that are combined. A compound is a type of matter that has properties different from the properties of each element in it. So a really good example of this is, how about this one? We haven't talked about this one, NaCl. Anybody know what that is? That's salt. That's table salt. We'll look at sodium. If we looked on a periodic table, it's a solid. Sodium is actually very, what I want to say, if you put pure sodium in water, it'd explode. It's very unstable. Chlorine is a gas. You put these two together, they form a solid called salt, which our bodies actually need in order to survive. Another good example of a compound is water. You take two gases, you combine them, and you get a liquid. It's completely different. These two right here, when you combine them, are going to be different than salt. Now, a molecule is formed when two or more atoms join together chemically. Prior to this, remember we talked about how you can have H2. You can have two hydrogens come together. This would be a molecule. H2O is a molecule. But a compound is a molecule that contains at least two different elements. So H2 is not a compound, but H2O is a compound. So all compounds are molecules, but not all molecules are compounds. And the reason for that is compounds have to be different elements, where molecules is just combined atoms in general. So molecular hydrogen, H2, the example I just used, and molecular oxygen, O2, are not compounds because each is composed of a single element. And you haven't seen O2 before in our notes, but this is what we breathe in. We don't breathe in pure oxygen. It would actually kill us. We actually breathe in a diatomic molecule of oxygen. Now, water, H2O, and carbon dioxide, CO2, are compounds because each is made from more than one element. So because there's two different elements in it, it would be considered a compound. Would it be a molecule? Yes, it would also be considered a molecule because molecules are just combined atoms in general. A mixture, when two or more substances are combined and each substance keeps its own physical and chemical properties after being mixed. Salt and sand that come together. Salt water is a mixture. Kool-Aid is a mixture. The Kool-Aid, I don't know if you've ever forgotten to stir the water in Kool-Aid. Well, if you forget to stir it, you definitely know it's a mixture because it's not combined yet. You haven't stirred it. A solution is a mixture that is mixed evenly throughout. So if you forget to mix the Kool-Aid, I guess it's not technically a mixture, but once you stir it up, it would be considered a solution. It's in solution. You're not drinking a solid anymore. You're drinking a liquid. And the dissolved substance is called the solute in a solution, and the liquid used for dissolving it is called the solvent. So that does conclude part 4 of our notes. If you have any questions, or actually part 5 of our notes, if you have any questions, just please ask your teacher and or myself if I have you in class, and make sure you keep studying, make sure you keep taking good notes. It'll help you in class. Thank you.